General Physics 2 is brought to you by Physics Classroom. Here are solutions to problems involving electrostatic force using Coulomb's law. Solve the problems below. Number 1. A pith ball is a small light ball that can easily be charged. What is the magnitude of the repulsive force between two pith balls that are 8 centimeters apart and have equal charges of -30 nanocoulomb? Number 2. How strong is the attractive force between a glass rod with a 0.7 microcoulomb charge and a silk cloth with a -0.6 microcoulomb charge, which are 12 centimeters apart, using the approximation that they act like point charges? Here's the solution to problem number 1. Using Coulomb's law, we get a repulsive electrostatic force of magnitude 1.27 times 10 to the -3 Newton. Since the two are like charges, they are both exerting a push of 1.27 times 10 to the -3 Newton. And for problem number 2, here's the solution. Using Coulomb's law again, an attractive electrostatic force equal to 2.63 times 10 to the -1 Newton is obtained, and since the two are unlike charges, they are both exerting a pull of magnitude 2.63 times 10 to the -1 Newton. Number 3. For the charge configuration shown below, calculate the resultant force on Q sub 2. If Q sub 1 equals 2.3 times 10 to the -7 coulomb, Q sub 2 equals 4 times 10 to the -6 coulomb, Q sub 3 equals 3.3 times 10 to the -7 coulomb, R sub 1 equals 2.5 times 10 to the -1 meter, R sub 2 equals 3.7 times 10 to the -2 meter. And for the solution to problem number 3a, let us determine the force acting on Q sub 2, due to Q sub 1. Since Q sub 1 and Q sub 2 are like charges, the force that exists between them is a repulsive force. By using Coulomb's law again, we get the magnitude of electrostatic force equal to 1.32 times 10 to the -1 Newton. This means that Q sub 1 is pushing Q sub 2 to the right direction. And now let's have the solution to problem number 3b. Let us solve for the magnitude of the force acting on Q sub 2, due to Q sub 3. Since Q sub 2 and Q sub 3 are like charges, they are both exerting a repulsive force. This means that Q sub 3 is pushing Q sub 2 to the left direction. By using Coulomb's law again, we get the magnitude of electrostatic force equal to 8.68 Newton. And finally, let's determine the net force acting on Q sub 2, due to Q sub 1 and Q sub 3. Since both forces between Q sub 1 and Q sub 2, and then Q sub 2 and Q sub 3, are repulsive, this means that Q sub 1 pushes Q sub 2 to the right direction by a positive force of magnitude 0.132 Newton. And then Q sub 3 pushes Q sub 2 to the left direction by a negative force of magnitude 8.68 Newton. Since the forces are acting on opposite directions, then we have to subtract. Thus the net force F sub R equals 0.132 Newton minus 8.68 Newton is equal to -8.55 Newton. Therefore, the net force acting on Q sub 2 is 8.55 Newton to the left. Here's hoping that you have an electrifying realization and enlightenment of how electrostatic force between charges behave. Thank you.